Welcome to the LemnaTec Academy. Working with LemnaControl. The LemnaTec software suite consists of apps that cover different working steps. LemnaControl serves to control the system, to do technical settings, and to record images. LemnaExperiment is for experiment management and to run analyses. These analyses are programmed in LemnaGrid or Lemna3D. Finally, LemnaExperiment serves to display the results of the analysis. Here we focus on image recording, so on the usage of LemnaControl. The analysis and the related apps are part of a different training. The system control software, LemnaControl, has several functions. The first function is the selection of cameras. This depends on the configuration of the phenotyping system. Phenotyping systems can have one or more cameras. For instance, an RGB camera or more RGB cameras, hyperspectral or multispectral cameras, laser scanners, fluorescence cameras, chlorophyll fluorescence cameras, NIR or IR cameras. Each type of camera, the relevant settings are available in LemnaControl, for instance light, exposure or scan speed. If the phenotyping system has any mechanically moving parts, positioning is also available in LemnaControl. For instance, there might be settings for moving parts such as conveyors that bring plants into imaging cabinets and back. If the system contains a weighing and watering station, these settings are available also in LemnaControl. You have already noticed that LemnaControl is always adapted to the respective phenotyping hardware. Differences in hardware and functions are reflected by the respective interface of LemnaControl. Here you see examples for a PhenoAIxpert HD, for a HyperAIxpert, and for a PhenoAIxpert Pro. In the rest of the presentation, I focus on the PhenoAIxpert Pro. For each phenotyping system, we have a dedicated training. This also comprises the differences in the LemnaControl interfaces. So if you are working with a specific system, please refer to the training for your system. Let's start with LemnaControl for the PhenoAIxpert Pro. This is the start page. The start page has buttons for operating the PhenoAIxpert Pro and buttons for service. To start working, we first need to initialize the system. Therefore, we click onto the Initialize Shutdown System button. On the Initialize Shutdown page, we can initialize the system when we start working, and we can shut it down when we finish working. To start, press the Initialize button. Then the system starts up and it gives a message when initializing is finished. Also, the shutdown button becomes active so that you could switch off the system when you do not need it anymore. If there is an error during initializing, this error will be reported here on the page. It will be marked in red. As a first troubleshoot, Check all connections of the system and computer, switch everything off and on again and try it again. If the error persists, use the copy output to clipboard function and report the error to the service. The data handling monitor tracks all actions of the system. It also tracks if an error occurs during operation, so it is helpful for troubleshooting. The service button is for our software engineer accessing the system for service issues. After initializing, navigate to the sensor unit configuration page. If you have already stored configurations, you can navigate directly to recording, but we do it step by step, showing the sensor unit configuration and the recording configuration steps that are required to do before the first recording. To do a sensor unit configuration, access the cameras via the respective buttons. After clicking on the camera button, the camera settings fields are shown. Here you can do all necessary settings for operating the camera. On the bottom, there are two buttons for white balance. The values are preset by LemnaTec. Normally, no change is required. Only change them if the color of the images does not match. With the light switches, you can switch on and off the light panels in the PhenoAIxpert Pro. As default, the light in the same direction as the camera is switched on and the other is off. So if you choose the side direction camera, also the side direction light is on. You have the possibility to change the light setting by switching both on or only that one on that is in the different direction as your camera. The most important setting for the camera is the exposure. Here you can change the brightness of your image. When working with the side-directed camera, it is meaningful to apply the Turner unit, which allows a multi-view imaging of the plant. For the turning unit, there are three different settings available. Most important is the rotation angle, so the angle in which your plant is turned in front of the camera. Rotation speed and wait time are used to adjust eventual shaking of the plant. So if a plant is very delicate, you should turn it slowly and give some waiting time after the turning. For robust plants, you can speed up the turning and minimize the wait time. This speeds up the overall process of the imaging. How to change a setting? Let's have a look at the exposure. Let's set a different exposure value using the Set button. The exposure setting window opens. Here we can give the exposure time in microseconds. As an example, we switch from 50,000 to 60,000 microseconds. The changed value is displayed, and the word changed indicates that for this setting a change has been made. If we want to stay with the change, we press the Apply Changes button. After changing settings, we can do a test measurement to see how images look like with the changed settings. This is useful to optimize settings, for instance finding an appropriate exposure time. When pressing the Test Measurement button, the camera takes an image with the current settings. The image opens in a new window. Here we can zoom in the image and center it. There is a function to check for over and underexposed areas in the image. You can spread the contrast. With a crosshair, you can check where the center of the image is and whether your object is in the area of the center. And you can set histograms at certain points in the image. If you wish, you can save the preview image. This is not mandatory. Next, let's have a look at the Turner settings. In most cases, you can stay with half maximum speed, so 50%, and a Turner wait time of 1 second. Only modify that if you see that the preset settings do not work well. The important part is setting the rotation angle. Let's see how this works. After clicking Set Turner Angle, the Turner Angle window opens. Here we can type in the desired angle of turning. The turning unit can take one full circle. In the example, we set it to 90 degrees, meaning we let the plant rotate by 90 degrees. When we have done settings that we want to use for recording, we can store these settings as a configuration. Therefore, we have the Save button. When we have done settings that we want to use for recording, we can store these settings as a configuration. Therefore, we have the Save button. By pressing the Save button, the Save Sensor Unit Configuration dialog opens. We can give in a name and a description. For each field, name and description, please give in minimum 3 characters, then press OK to save. After saving, the configuration appears in the list. From here, you can also load configurations for modifications. When the sensor unit configurations are done, we can set up recording configurations. To do so, we combine sensor unit configurations to a recording configuration. First, we navigate to the camera, for which we have stored sensor unit configurations. Then we select one or more of these configurations and add them to the recording configuration. A recording configuration can comprise sensor unit configurations for one or more cameras. With the Save button, we can save a recording configuration and give it a name and a description. Again, each field expects at minimum 3 characters. Now we are ready to start recording. We move to the recording page. Before recording, we need to select a recording configuration, give an experiment name and a sample ID. We select a recording configuration from the stored list and type in an experiment name and an ID. By pressing the record button or hitting F1, we start the recording. Images are stored according to the recording configuration. This is the mode for free configurations. Next, we have a look at prepared configurations. Prepared configurations are stored in CSV files that we need to load before recording. Here we only need to type in the sample ID. If we select a sample ID that is not in the prepared file, nothing happens. If we select a sample ID that belongs to the prepared file, the system automatically adds the experiment and the recording configuration. Again, we start recording with F1 or the record button. Instead of typing in sample IDs, we can also use a barcode scanner. Let's have a look at a CSV file for a prepared configuration. A CSV file for a prepared recording configuration has three columns. First, the sample names, second, the experiment name, and third, the recording configuration. To prepare such a file, list your samples and give a name to the experiment. Put an existing recording configuration into the third column. Then save the file as CSV, and after this you can call this CSV file from the LemnaControl software. After finishing the recording, return to the Initialize Shutdown page. Press the Shutdown button to close down the system. Then you can close the software and also switch off the PhenoAIxpert Pro. This video has covered the introduction to the LemnaControl software in case of a PhenoAIxpert Pro. We will provide trainings on hardware and control software with any of the hardware pieces that we deliver. As mentioned earlier, LemnaControl always is made corresponding to the current hardware. So differences will occur in the software interface, and we will explain them in the corresponding training. For some types of phenotyping systems, introductory videos on how to use the hardware in combination with LemnaControl are given in our YouTube channel.